Geometry, Chapter 2, Review. Here we go, guys. It says, which statement is a counterexample for the following conditional? If you live in Springfield, then you live in Illinois. Well, a counterexample is what's going to prove that statement false. Sarah Lucas lives in Springfield. That does not prove it false. Jonah Lincoln lives in Springfield, Illinois. Billy Jones lives in Chicago, Illinois. Aaron Naismith lives in Springfield, Massachusetts. D is the answer here because it proves the statement false. So number 1 is D. Number 2 says, in the figure shown, the measure of angle AED is 120. That's that angle right there. It's 120 degrees. Which of the following statements is false? Angle AEB is 60. AEB, that's this angle. And it is 60 degrees because the two of them are a linear pair. So that one's true. The measure of angle BEC and CED, that's BEC is this angle, and CED is this angle, and it says that they are adjacent. Yes, they are. They're adjacent. So that one's true, and that one's true. The measure of angle BEC, right here, is 120 degrees. That's also true because it's vertical with this angle, or you could say it's supplementary with the 60-degree angle here. Angle AED, that's this angle, and BEC, this angle, are adjacent. That one's the one that's false. Those angles are actually vertical angles. And they're congruent angles, but they are not adjacent angles. 3, how are these two angles related? These two angles are supplementary. They are not adjacent because they do not share a side. They're obviously not vertical or complementary either. Number 4 says, identify the hypothesis and the conclusion of this conditional statement. If two lines intersect at right angles, then the two lines are perpendicular. So for number 4, the hypothesis, that's the hypothesis, and that's the conclusion. Number 5 says, write this statement as a conditional in if-then form. If a figure is a triangle, then it has 3 sides. That's what they want to see. If a figure is a triangle, then it has 3 sides. Number 6. Another name for an if-then statement is a conditional. Every conditional has 2 parts. The part following the if is the hypothesis, and the part following then is called the conclusion. Number 7. What is the conclusion of the following conditional? A number is divisible by 3 if the sum of the digits of the number is divisible by 3. The number 7, what is the conclusion? The conclusion is the part that says the number is divisible by 3. The word if comes right before the hypothesis. I realize they've left out the word then in this problem, and they've rearranged the order for what we're used to. But what is the conclusion? It is this. This is what you can conclude if this statement falls true. Number 8, what is the converse of the conditional statement? Well, the converse of if a point is in the first quadrant, then its coordinates are positive, would be this. If the coordinates of a point are positive, then it's in the first quadrant. So the converse is where you take the conclusion and the hypothesis and you switch them. So that's number 8. Number 9 says, what is the converse and truth value of the converse of this conditional statement? The conditional statement says if an angle is a right angle, then its measure is 90. So the converse says if an angle has a measure of 90, then it is a right angle and it is true. Number 10. For the following true conditional statement, write the converse. If the converse is also true, write the statement as a biconditional. And we would write for the converse, if x squared equals 9, then x equals 3. But that is false because x could also be negative 3. So we cannot write that as a biconditional. We cannot use the if and only if because the converse was not also true. 11. Determine whether the conditional and its converse are both true. If they are, combine them as a biconditional. If either is false, give a counterexample. So it says here, if two lines are parallel, they do not intersect. That doesn't use the word then, but it would be right there. Right there would be the word then. If two lines are parallel, then they do not intersect. Okay? That's true. The converse says, if two lines do not intersect, then they are parallel. Well, they could be parallel, but they could also be skew lines. So we have to call that statement false, and the counterexample would be skew lines. Now, skew lines are lines that are in different planes that do not intersect. Number 12, write the two conditional statements that make up the following biconditional. I drink juice if and only if it is breakfast time. So for number 12, the first thing that you want to write, your hypothesis is right here. It's always listed at the front. If I drink juice, then it is breakfast time. And the converse of that would be if it is breakfast time, then I drink juice. Okay, that's number 12. Number 13, when a conditional and its converse are true, you can combine them as a true biconditional. And that's on the board. That's one of those things that's up there for you to refer to. So you should get that one right. Definitely. Number 14. Use the law of detachment to draw a conclusion from the two given statements. If two angles are congruent, then they have equal measures. P and Q are congruent. This statement refers to the hypothesis, and it restates it. It says that that hypothesis is true. So you can conclude that the measure of angle P is equal to the measure of angle Q. You can conclude that those two angles have equal measure. 15. Use the law of detachment to draw a conclusion from the two given statements. If not possible, write not possible. I can go to the concert if I can afford to buy a ticket. Okay. So for number 15, here's your hypothesis. Here's your conclusion. Okay? It's written reverse from what we normally would see. If I can afford to buy a ticket, then I can go to the concert. The I can go to the concert part ties to the conclusion. So there is not a possible to draw a conclusion here. Now, I want you to put a star by that one. That one's kind of challenging because of the order, And I'm probably going to count that one as a bonus on the test. So if you get it right, good for you, but I acknowledge the fact that that one is a little bit tricky. 16. If it is possible, use the law of detachment to draw a conclusion from the two given statements. If it's not possible, write not possible. So 16 says, if x equals 3, then 3x minus 4 equals 5. And then they say, okay, x equals 3. Well, that's restating the hypothesis, saying the hypothesis is true. So you can conclude that 3x minus 4 is equal to 5. 17. Use the law of syllogism to draw a conclusion from these two given statements. If a number is a multiple of 64, then it is a multiple of 8. If a number is a multiple of 8, then it is a multiple of 2. So your conclusion would be to take the original hypothesis and the last conclusion and put them together. If a number is a multiple of 64, then it is a multiple of 2. Okay, number 18, find the missing reason. It says the measure of PQR is x minus 5, and the measure of SQR is x minus 11, and that PQS, the whole thing, is 100. So, what did they do first? The measure of PQR plus the measure of SQR equals the measure of PQS. So the first one here is the angle addition postulate. Two little angles added together will give you a big angle. Now they substituted the algebraic expression for each of those angle measures and then the value of 100 for PQS, so you use the substitution property. And then we simplified the left side. And then what did we do from C to D? From C to D, we used the addition property of equality, and then we divided. Okay, number 19, algebraic problem where they're giving you 11x minus 6y equals negative 1 and the fact that x equals 8, and this is what they want you to prove. So they set this up. They write out the given information. So the first part of this one is given. And the next thing they do is they take that 8 and they put it in place of x. So for part B, they've used the substitution property. And you know what else they've done? They've multiplied. The book only has substitution property, but I know and you know they multiplied. I want you to put that down too. The next step looks like they subtracted 88 from each side, so this is the subtraction property of equality. And then they divided, division property of equality. And then what did they do? These are the same except for the way they wrote them. Now, it's not the reflexive property. What they've done is they've used the symmetric property, because they have just reversed it. If it was reflexive, you'd have y equals y, or 89 over 6 equals 89 over 6. But since they used these two and they flipped them around, it's the symmetric property. Number 20, find the missing reason here. It says, given that the measure of angle 1 and the measure of angle 3 are the same, prove the measure of angle AFC is equal to the measure of angle DFB, and that would be this angle and then this angle from here to here. Now, might sound like kind of a tough task, but all you really have to do is find the missing step, okay? They start out with the measure of angle 1 equals measure of angle 3, and that's given. And then the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. Now we went from this line to this line. What we did was we added the measure of angle 2 to each side. That's the addition property of equality. Now, the measure of angle 1 and the measure of angle 2 make up angle AFC. The measure of angle 3 and the measure of angle 2 make up angle DFB. So what did we use there? Angle, addition, postulate. And so then we can say that then, since that and that are equal, these two angles have to be equal as well by the substitution property. Number 21. Given that the measure of AOC is 150, that's that big angle, we start here and we're solving for x. The measure of angle AOB plus the measure of angle BOC equals the big angle. That is the angle, addition, postulate. Then we replace those measures with their values, so that is called substitution. This is property and not of equality because we didn't do it to both sides. Then we distributed. The next thing we did was simplify. And then we added. And then we divided. Division, D-I-V-I, property of equality. I should have written division instead of divided, but these are your steps for 21. 22, similar type problem, ask us to fill in the missing reasons. Now, AC, that's from here to here, is 32. First step says AB plus BC equals AC. That's not the angle addition postulate, that's the segment addition postulate. Then we replace those segments with their values, so that's called substitution. In the next step, we combine 2x and 6x, so we simplify. And then we subtract 8 from both sides, so it's the subtraction property of equality, and then we divide. These proofs are not difficult if all you have to do is give the reason. You just have to go through and just state what you did each time. 23. Name the property of congruence that justifies the statement. If segment XY is congruent to segment WX, then segment WX is congruent to segment XY. Those are the same two angles. They've reversed their order or they've moved them around, but they're still congruent. That is symmetric. The next one, if angle A is congruent to angle B and angle B is congruent to angle C, then angle A is congruent to angle C. So there's three things. We're transferring congruence from A to B and then B to C. That is the transitive property. Use the given property to complete the statement. Transitive property of congruence. If segment CD is congruent to segment EF and segment EF is congruent to segment GH, then segment CD is congruent to segment GH. 26. Name an angle supplementary to EOD. Here's EOD. Supplementary could be this angle, angle COD, or this angle, angle AOB. Either of those would work. 27, find the value of x. These two angles are vertical, so 7x minus 8 equals 6x plus 11. And then you just solve using algebra. So x minus 8 is 11. Add the 8. X is 19, but Is that what they want you? Yes, that's what they want you to do. My book has negative 19. Where did that come from? 7 minus 6 is 1. Did I miss a sign in there? Let me stop this and see. Okay, 28. Find the values of x and y. Well, this angle and this angle are congruent because they're vertical. So 7x plus 7 is 112. So I'm going to solve for x. I'm going to subtract 7 from both sides. 7x is equal to 105. I'm going to divide by 7. X is 15. If x is 15, then this is 7 times 15 plus 7. So I'm going to add that to 4y, which is 112. So 112 plus 4y should be 180 because those two angles make a straight line. I'm going to subtract 112 from both sides. So 4y is 68. Divide by 4. Y is 17. So x is 15, y is 17. 29. Write the converse of the given true conditional and decide whether the converse is true or false. If it's true, combine it to form a true biconditional. If it's false, give a counterexample. If the probability of an event will occur is 0, then the event is impossible to occur. So the converse would read, if the event is impossible, then the probability is 0. That statement is also true. So to write it as a true biconditional, we would write an event has a probability of 0 if and only if it is impossible to occur. Okay, missing terms. Let's see here. Given that angle 1 and angle 2 are congruent, the measure of angle 1 is 130, prove the measure of angle 3 is 130. Okay. Angle 1 is congruent to angle 2, and the measure of angle 1 is 130. That is given. The measure of angle 2 is 130. Well, what do we use there? Substitution. If you use transitive property, I would probably say that's okay because 1 and 2 are the same and then they're equal to 130, but substitution's the best one. Angle 2 is congruent to angle 3. Why? Because they are vertical. Vertical angles are congruent. That's the vertical angles theorem. Therefore, measure of angle 3 is 130. We've used substitution again. Okay, I hope that you've written these down and have this ready to turn in for your bonus points this time. Good luck on the